talk about how do you track your server performance? How do you know if your server has performance issue or not? For example, with hardware upgrade, with OS changes, with server version upgrade. And hopefully, as a server admins, we will find out the server performance issues, potential issues, even before the users tell us. And then Lawrence will talk about all the basic stuff that is so critical for server and admins, backup, restore, and DR. We are going to keep everyone muted for better recording quality. Please click Q&A button if you have any questions. I think at the end of Matt's presentation, he will answer a few questions. And myself, I will monitor the Q&A questions and try to answer some easy ones, like where do we post those recordings? And then at the end of this presentation, we will have dedicated Q&A time, try to answer all of your questions. Without any further ado, Matt, why don't you take it over?
Cool, thanks, Mark. Hey, everybody. I'm Matt Coles. I'm Principal Systems Analyst with Tableau. You can find me on Twitter under Mr. Data Grabber, although I never post, so don't really bother. If you could ping me, but I won't answer because I don't like Twitter. But there's a spot there, so I put my Twitter info. This is me. I've been at Tableau for 7 years, since 2012. I initially started doing ETL of our Salesforce data, and then I moved into Tableau Server admin role. So I was managing a Tableau Server for all of Tableau. And now my primary role is talking to customers about how we run Tableau at Tableau. So going back to my early days, more in the weeds as a server admin for Tableau, I would be adminning at my desk, and all of a sudden people would start complaining, why is the server so slow? I just get a spinner. Is something wrong with Tableau? And that was very disruptive to my hard adminning work, as you can see that I'm trying to do there. And I've always found that it's best to take a slow and methodological approach to kind of help you through reasoning what the problem is with server in those situations. First, try to make some observations, collect some information from your users, try to think of interesting questions as to what might be the problem, formulate your hypothesis on what the problem could be, think of how you could test that hypothesis, gather data nope, everyone's upset and they're all angry because you've taken too long to resolve their problem. You don't have time for the scientific method when you're trying to fix problems with your server. Every time I've tried that approach, it has not worked well for me. So really, you need something that is faster. You need a panic button. You need your answers now, and you need to know what's wrong. How do I fix it? You can't take the time to go into performance recordings on an individual visit because your users have an issue and you need to figure out at the admin level, what is the fastest way I can make them happy. And so for me, that always means checking the worst case scenarios first as quickly as I can. And that worst case scenario is there's a fundamental problem with Tableau Server. So if we can rule that out, then it makes everything a little less urgent and a little less critical. And maybe hopefully even someone else's fault. So let's talk about the tools that we have at our disposal to do that. So everyone should be pretty familiar with the status page on Tableau Server. There's the ever helpful status screen that shows all of the nodes of Tableau Server that are running, all the processes that are running there. And that actually is a very good way to go and see if there's a high-level problem with Tableau Server. You can see if the processes are down. Everyone should be checking that first. I think, in my opinion, just because it's a very quick and easy way to eliminate substantial catastrophic issues. There's a couple other things on this page that you can also look at that you probably are also already familiar with. They're down here. They're the admin views, vizzes that tell you about how server is doing. So we have one called stats for load times, which shows you the load times for various vizzes and a little bit about the performance history. And then you have another, which is the performance of views, which gives you sort of an overall look at how views are performing. So let's take a look at those and see what they can do for us. So stats for load times. This is what it looks like on my server. It doesn't actually render. We have a very high traffic server, and generally we get timeouts on this Viz because there's so much data it's trying to crunch. This is what it looks like if you do get it to render. And right off the bat, you can see that we have a line chart showing the averages of what the overall Viz load times are for the server over the last hour. And that could potentially be helpful, except that an hour is not much context to go off of to tell whether you're having a performance issue. Typically, you need a little more data and history than that to see if what you're seeing right now is actually slower than what you do normally expect. And then down at the bottom, you have individual load times in a sort of scatter plot for each Viz, which could be helpful, except again, you don't really have historical context on it. So you can't tell what should this Viz be rendering at versus what it's currently rendering at. So a little bit challenging to answer that question quickly and easily with this Viz. The next one is the performance of views dashboard. And it's actually a little more helpful if you can get it to render, which I usually can't on my server. And I should say, I'm not trying to take pot shots at Tableau server here. It's mainly that I'm a practical admin. I have a job to do. I need to do it, and if the tools get in the way, then I need to find some other way to do my job. So I'm not bashing on Tableau server, but it has been necessary for us to come up with other ways to do this. But let's talk about this Viz when it does render. We have an area plot at the top that shows us the percentage of views that render in certain time frames. So if they're fast, they're in green. If they're slow, they're in red. And that's actually not a bad way to visualize things and kind of take a look at how a server is doing. In this case, we have 7 days worth of data to go off of, so that's better. We might actually see some performance trends that way. And down below, again, we have the individual views and kind of a traffic view that gives us number of sessions. This Viz still has some issues, though, in that 7 days seems like a lot, but it's not actually always sufficient. And the other thing is, because we are looking at the number of seconds it takes to load a Viz, and we just have basically a count of a percentage of requests, if you add a new Viz to server that is high traffic, it can skew these results quite badly. So if you added a view that all of a sudden was taking 10 seconds and half your company was looking at it, you'd see a great increase in the red on this chart, even though Tableau server is not actually having an issue. It's just that the Viz itself is skewing the results. So the same thing could happen if you add a fast Viz that's popular. So there are some skewing issues that this can cause. If you break down this chart, and this is a custom view that I made based on that last chart, in which I break one row per popular Viz that we have, you can see that each has kind of a different performance profile with it. So the load times for each Viz are not the same, and not even consistent within the Viz half the time. And likewise, you can see in the fourth row down, one Viz people completely stopped looking at it. So this is one of the most popular Vizes on the server, and all of a sudden they stopped looking at it. And the one just above that, people were looking at it sporadically, and then all of a sudden they started hitting it hard. So we have all these different variables that are going into our chart that could end up skewing things that really don't tell us at a high level what server is performing at. It's just we're not calculating things in an even way. So here's an illustrated example of why this can be a problem. So 70% of our server traffic right now at Tableau internally is attributable to 3 Vizes. So if any of those 3 Vizes have a new version published that's slightly slower or slightly faster, or they stop using that one, it can really change things in that previous Viz that I showed. So let's go over the problems real quick. We don't really have enough data. 7 days is not really enough for a baseline, even though sometimes it can seem that way. They're slow. They don't always render, and we need that information now. We have users complaining. The metrics can be susceptible to skewing. So popular Vizes can skew those things. They just tend to dominate the information that's rendered in there. New Vizs being added, removed, or stopping, if they stop working and they stop loading that view at all, it can look like a server-wide problem when it's really not. And the other problem is because they're admin views and they're built into Tableau Server, we can't build alerts on them. That's just not a function that's unfortunately supported right now. So the reason we need an alert is we really want to know when something is happening right now. We don't want to wait till users complain. We want to know it before they know so that we can fix it before they start complaining, because that improves the user experience for everyone. So let's talk about a proposed solution. Step one is that we need to get data. We need good data on performance. It needs to be timely and it needs to be able to be rendered quickly. So one solution that I have to offer there is a community post at the link above. If you go to that link, you'll see a series of data sources that I've published to the internal community, or the external community, I should say, that help you analyze all of the information on Tableau Server. One of those data sources is called TS Web Requests. And basically what it does is it looks at the HTTP requests table within the Postgres database of Tableau Server, and allows you to, if you take an extract of that information and you set it to incremental based on the ID field, and you just keep incrementing that and you don't do a full refresh, you will accumulate performance information from Tableau Server. And if you do it incrementally, it shouldn't be that big of an expense to your server, and you'll get plenty of historical data. I recommend just letting that thing accumulate. We've been doing it since, I want to say September of last year. And it is a big extract, but it's been so valuable for analyzing information on server that we just keep it around. If you do need to truncate that extract or trim it in some way, Tableau Prep Builder will actually let you do that now. So you could extract the hyperfile from the TW or the TDSX and then shorten it with hyper, just set it to a date. And I'm not going to go over how to do that in this presentation, but basically there's ways to trim the extract without having to take a new full refresh and trimming it down all the way to 7 days again. So you can keep all the historical data and not let it get super huge. So let's talk about the key fields in this data source. As you can see, we've got some nice foldering happening so that you can actually navigate this fairly easily. And I've highlighted the key dimension fields here, and we'll go over each one really quickly. So we have the actor user system name. So that's the username of the person who is sending the request. And in this case, we're interested in Viz Loads. We have the item repository URL. So what that means is it's basically a unique identifier for the views that we care about. So which view is being rendered. There's the action field, which is really important. And this information is not documented anywhere sufficiently that I've seen. So this comment, if you hover over this field, you'll see all the bold are sort of the most common and important actions to be aware of. And I've documented those there. The Bootstrap session is really the one we care about for this, and I'll go into what that means in a slide in a few minutes. But basically it means when a viz is being rendered. We need the created at in the local time zone. That's basically when the request happens, so that's the date. What worker machine in your cluster, in your Tableau Server environment, in your deployment, which one received that request and acted on it. And the site name is also important, just to know, which sites exist, because you need that to distinguish this actor user system name. So for measures, really we just have one that we care about, and that's the duration in seconds that the request took. So if we're concerned with Viz loads, that's how many seconds the viz took to render. Okay, so let's talk about bootstraps. So if the action field in that data source says bootstrap session, then that means it was an initial viz load in a browser. So someone actively went to a browser and rendered that viz. Things that it doesn't capture are other actions that they might take on the viz. So if they've got that rendered in their browser and they're clicking on marks and they're doing filtering, that stuff isn't being captured under the bootstrap session. So right now we're just going to be measuring bootstraps, and that means the initial viz load. It also doesn't capture if they click another viz from that same workbook. So just be aware of what this means and things that we're kind of ignoring when we look at just bootstrap sessions. And really, it is a little bit of an incomplete view of the Viz Load time because there's actually more components to a Viz Load than just Bootstrap. There is a load view request that you could find under the show action. You'd have to take that and the Bootstrap session and add those durations together to get the closer look at what the real Viz Load time is. The reason we can't do that is because there's no way to tie those two requests together in our data set. So we don't have the request ID that would let us say, oh, this show goes with this Bootstrap session. And it turns out that's okay because the Bootstrap session really does have the majority of the work happening anyways, and the show really doesn't usually take very long. So Bootstrap is still a good proxy value for how long did the viz take to load, and that's really what we care about. All right, so we've got our data. We've got it incrementing all the time. We're collecting all this information on how long vizzes take to load. Now we need to figure out how to interpret that data in a meaningful way that lets us tell whether a server is being slow right now or not. Okay, so for our metric, what we want to do is we need something that's easy to see at a glance, just how is server doing? That's what we care about. It has to answer our question. We don't want it to be skewed by a single viz's behavior. We should be able to add or remove vizzes without really affecting the overall metric too much. Any given viz having a performance issue shouldn't send a server-wide panic. We shouldn't see that there are server problems based on a single viz, basically. We have to go back in time and be able to see what those historical values were. And we also need to, we need that because we need to see what the alert threshold that we want to set should be. You can't really do that without a history. And we also want to go back and research, when these things did happen, what was happening at the time. So that has to be preserved. If we're doing some kind of table calc that's always updating based on the current values, and it's updating our old values based on what the new values are, we can't have that happen. And we need something that we can send an alert on. So that means we have to condense everything to a single number. It has to be a measure value, and that has to be something that we can trust to be not very noisy. It has to have a low number of false positives. In other words, we don't want to be alerted all the time for no reason, and we don't want to miss true performance problems when they do happen. So all of that is actually pretty difficult. I've tried for years to create something that's useful based on averages, and I was just never happy with the results. I would either get false positives or it would not tell me when there was an issue. And frankly speaking, even today, the solution I'm going to share with you isn't perfect. It still has some issues, but I'm happy enough with it that we use it to monitor our production server right now as one of our key metrics for how server is doing. And it is actually pretty darn good at telling me when there's a problem before other people know that there's an issue. But before we get into that, we need to do a little refresher course on basic statistics. And full disclaimer, I did pretty badly in college in the statistics class I took. So anyone who actually knows statistics out there can feel free to chime in and correct me on the Q&A and email me later and tell me, hey, or send it to Twitter. Tell me that I've misinterpreted something. Because at the end of the day, I'm just an admin trying to do a job, and if stats are the right tool for it, then I'll try and learn about it and use it. But I'm by no means a professional. So let's look at some viz load times. We have 3 different vizzes being loaded here. The gray marks are all the fast viz that gets rendered all the time. It's a very popular one, and each one of these values is how long it took in seconds. The pinkish beige color is the slower viz. So it doesn't get looked at quite as often, but it's a little bit slower. And then we have a yellow viz that everyone hates, and it takes super long, so nobody usually goes to it. So that's our data set that we're going to work with right now. We could take a simple average of everything, which means we're going to add all the load times and divide by the total number of loads. So add all those together, we get 641. The total number is 19 viz loads. So it's 641 divided by 19. So our average viz load time for all of server in that time period is 34 seconds. And 34 is kind of a lot. It's kind of high because most of the viz loads that we have, and 18 out of the 19 are far under that. So what's happening is that 572 is skewing it higher. So if that 572 hadn't been rendered in this time period, our rendering time would actually be way lower, probably less than half that. So just by virtue of someone clicking a button, we would be skewing our metric way high, and we don't want that. We could also use the median. So that's kind of designed to help avoid that problem of skewing by large values. And to calculate the median, we just sort the list of values and we pick the middle one. So in this case, we're picking the middle value. This is a sorted list. It's not actually quite perfect, but it's close enough. So the value would be 1. 1 is the median load time for server. But the problem with that is our common values really skew that. So if we have a super fast viz that's loaded all the time, we can really skew down to what that common viz has. So we don't really want that either. So let's take a different approach. What if we treated each viz separately? So let's say we had each of these as its own separate data set that we wanted to look at. We can calculate the average for each viz. So we have 1.5 seconds for the fast viz, 15.3 seconds for the slower viz, and 572 for the one everyone hates. All right, so now that we have that baseline, we could compare new viz loads against that average for that viz to determine if they're slower than normal. And that would give us a relative measure of how fast each of the viz loads that are coming in are. So how do we do that? Well, we can use a standard deviation to determine how slow each of these new viz loads are. And standard deviation is a measure of how variable a data set is. So if we look at just the fast viz data set, the average is 1.5 seconds. And yeah, standard deviation is going to tell us how much those vary from each other. The way you calculate that is you subtract the mean, so that's the average from each value, and then you square the result. So let's take the first value here, it's 1 second. We're going to subtract 1.5 from it because that's the mean. And we get a result that's negative 0.5. And so then we square that, and for that value we get 0.25. So I'll populate the rest of those up there. So we get 0.25 several times, and then we get 2.25 for the 3s, and it's still 0.25 for the 2s actually. So we take all those values, we average them, and then we take the square root of the result, and that gives us a 0.8 standard deviation for that data set. Okay, so that's great, but what does that help us do? We can define a slow viz load when it's more than 3 standard deviations higher than the baseline average. So if we get a new request coming in and that number is 3 standard deviations higher than what we had calculated based on our previous baseline, then that's what I would call a slow viz load. And so then we have something we can really measure. So here is a histogram of that fast viz, and this is real data from our server. Most viz loads happen in between 0 and 1 second. And so we have seconds, how long it takes to render across the bottom axis, and then the number of requests that fall into that bucket. And so you can see it generally renders very quick, and it has a very long tail of slowly loading requests that can happen. And so how many of those are 3 standard deviations above the mean? Well, those are the ones that we would consider slow, past the 9-second mark, based on just a manual calculation that I did for calculating the average and the standard deviation. So 16,000 requests doesn't really tell us much, though, because how important is that? How many requests do we have overall? What we need to know is the percentage of the total loads for this viz that are slow. So if I take that and I just plot that using an area chart, now I've got the percentage of requests that were slow in orange over time, and the blue represents, everything else. So vizes that were rendered in an adequate amount of time. And now you've got sort of a measure for how poorly performing a viz is over time. And you can actually look at that and say, things are slow right now for that particular viz. So that's pretty useful. But we need this to be a rolling average or rolling baseline, because we don't want to set one baseline for all time for each viz. Things change over time. Vizes get slower, get faster. People change them. New vizes come about. We don't want to go manually calculating that for everything. So what we're going to do is we're going to create a baseline based on a previous week's set of Viz Load data for every Viz. So every week, every time a Viz Load comes in, we're going to gauge it based on what the previous week's performance for that same Viz was. So why choose a week? Mostly because it encapsulates most of the variables that we have in a standard business time unit. So we have weekends and weekdays. Those can really skew how Viz's perform because of volume. Same with hour of the day. So during business hours, it's often, things can be cached that makes them faster, or it could just be general loads. So there can be a lot going into that. If we take it over the entire business week, then we tend to capture all of those things together. So why not just go further and create baselines for each day of the week and every hour of the day, and then gauge that same, Viz's render during the same hour and the same day of the week against the previous hour and the previous day of the week? Well, I tried that actually, and it didn't work because there tends not to be enough Viz Load data that way. You can't really create a coherent baseline with so few Viz Loads within a given hour. So the question we're going to ask is, for the previous Sunday through Saturday week, what was the average of the Viz Load times and the standard deviation of the Viz Load times for every Viz? So every Viz is going to have a separate calculation for both of these, so a separate value for both, because we want to gauge the Viz only against its own performance profile. So here is a visualization in which I show how to use LOD calcs to get this information. And this took me a long time to figure out. If you don't understand it, it's okay. I don't totally either, but try your best to follow along, and I'll try and make it visual so you can. Okay, so every column here is a different week of the year. So let's label at the bottom. Each one is the year it happened in, and then the number of the week within that year. So we have down at the bottom 2019-07, so that's the 7th week of 2019, the 8th week of 2019, the 9th week, and so on. So each row represents, in the middle here, we've got the average from even weeks, right? So every time we have an even week, so this is 2019-08, so that's an even week, we calculate the average for it. So a given Viz is average load time. And then we're actually going to perpetuate that to the next week as well, to the odd week. And then for the odd weeks down here, we're going to calculate the average Viz load time for this Viz. And we're going to replicate that data out to the next week. And what that allows us to do is get around an issue where LODs will not let you see a previous week's data in the following week. So we're structuring our LOD to actually span a 2-week period, so that during the current week, we can get the right value from the previous week because it's accessible, it's in our same data set. So we have these two staggered sets of data, and here we can pick the value from the previous week, so it's 9. And then in the next week, we know to pick the one from the odd week, so we're getting the 25, and so on and so forth, so that we're actually getting every week the previous week's load times. Hopefully that makes sense. It probably will make more sense to look at this picture than it does to look at the LOD calcs, but I'll show you the LOD calcs anyway, because some of you know this stuff really well, and will be like, oh, I get it now. So we are using a fixed LOD calc. We're fixing it to the item repository URL from our data set. So that means the Viz that's being loaded. So everything is being calculated at the Viz level. Each Viz is distinct from each other. And we're doing it over that 2-week period. So this LOD calc is just for the even weeks. We have a separate LOD calc for the odd weeks, and this represents a 2-week period. So this is how we're spanning both weeks with one set of data. We're taking the average, so it's just a simple mean of the Viz load time, because we're just creating a baseline. We're looking at Bootstrap session in the action field, because that represents what a Viz load is. And then this part of the LOD is just making sure that the values we're calculating are from that previous week. So that's just the even weeks we care about for the even week calc. And then for the odd week calc, we'll get the odd weeks. Okay, so once we have all that information and we've gotten our baseline value, figuring out whether a Viz is slow or not is actually pretty simple. So this first field is the duration of the Viz load itself. So how long did the Viz right now that's coming in, that's being rendered, take in seconds? We're subtracting the average value from the previous week for that Viz. So how long did it usually take last week? So if this is much slower, this will be a high number, right? So if it's 5 seconds and the average last week was 3, then you're 2 seconds over what the normal average is. And then we're dividing by the standard deviation of the previous week. So if it's a highly variable Viz, that will be a high value here, which means even if you went slower than last week, it might not matter that much because you could be well within the tolerance for that Viz just because it's always fluctuating. But if you've got a low standard deviation, it means we always expect it to be rendering at the same speed all the time. So any variance here, if it's much higher here, that will show a higher result. So that's more abnormal. Okay, hopefully you're still with me. Thanks for sticking it out. All right, so now we're getting to the fun stuff. Okay, so this is the actual performance dashboard that I built based on this logic. And I'll walk you through what each of these panes means. The middle pane here is kind of what we just talked about. So what it's showing is the percentage of requests coming in to Tableau server that are over 2 standard deviations for that Viz. So you can see that there's not a lot of noise going on. It's actually pretty static until we get to a real problem, and at which point there's a huge spike. And so it actually is a pretty decent measure for figuring out whether there's a performance issue with server. Because we're taking the total number of requests and we're just doing a percentage of the total, this can still be skewed by popular Vizes. So if you have a popular Viz misbehaving in a bad way, it can still skew this result. So that's something to keep in mind when looking at this. And then below is the same exact chart, but we've broken it out based on the worker. So we have 2 workers that are responsible for Viz loads, so VizQL stuff. We're running VizQL server on these 2 hosts, and so that's where we're getting data in. But you can tell just by breaking it out by worker, we have a massive issue here on worker 23, and on A22, we're not seeing that same spike. So we're going to go look at 23 and see what's going on with that in this scenario when that alert goes off. Now, going up to the top pane, this is actually probably the most helpful measure that I've seen for figuring out whether there's a performance issue with server. And what we've done up there is said, okay, we don't want one popular Viz skewing everything. So let's weight every Viz's average performance equally. So we're only going to take one value, and that value for that Viz is going to be the average standard deviations for that hour, and weight all of those once, and then we're going to take the median of those values, and that's what this represents. So this is actually a much more balanced way of looking at what server performance is overall, because it can't really be skewed by an individual popular Viz. Every Viz is treated equally. So if a massive number of Vizes are misbehaving, then you're going to see a big spike here, as we do here. If one Viz is misbehaving, it's not going to show up here. So both of these can be very valuable together, in that this represents when there's maybe something critical that's gone haywire, and this represents whether there's an underlying server issue that's affecting a lot of different Vizes, even if they're not critical. So very useful. And then I didn't show it because I ran out of room, but this is the bottom part of the chart. And what each row in this data set represents here is, it's the same exact one as before with the worker breakout, except that it's broken out by the top 30 most popular Vizes. So looking at that same time range, yellow representing the percentage of requests sent to that Viz or Viz loads that are slow, you can really see the patterns jump out. So here we've got a cluster of impacts across a number of different popular Vizes, and you can see another impact over here as well. So it's another way of sort of confirming visually, like, is what I'm seeing trustworthy? I have one single value. Do I believe that that's really representing an issue? And then when I go down and look at these Vizes, I can see, oh yeah, like we are seeing widespread impact to lots of different Vizes right now. And the other thing this is useful for is the gray lines here are actually just the total number of requests. So it's a dual axis chart. We're looking at number of requests. So when there's black, that means no one's looking at that particular Viz. So we actually have been able to catch issues where we've seen popular Vizes that have gone black for a while and said to ourselves, hey, what's going on with that Viz? Why is no one looking at that all of a sudden? It turned out it was an embedded Viz that had an issue that we were able to then fix. So there's actually other values you can get out of this. So yeah, just a few more examples. 1 second here. I have to remember what these are showing. So, oh yes, so this one was an issue where we lost a gateway. So you can see over here, things started going really badly across all of server. It's a little less apparent down here from the percentage of requests, but we did lose a gateway host. And that's what I saw when I went to actually pull up the Viz on our Tableau server instance. And so it became pretty apparent quickly that we were seeing a true issue, and it was because we had lost gateways. Most of the other issues, the actual one I was showing you earlier, this was when one of our workers fell out of the domain. So it just dropped out of the domain entirely. We talked to our IT team about that at length. But yeah, that was a pretty massive issue that we were able to identify pretty quickly because we had this alert set up. And going back to this, so one thing I noticed, actually let me jump back a slide or two here. One thing I noticed when I was looking at this top row is that whenever we did a server restart, you would see a pattern like this. So things were going badly, we would do a restart of server, all of a sudden the performance would drastically improve, but it would slowly degrade over the next several days to where it would actually get worse than normal, and then it would start balancing out again. We saw that over and over every time we did a server restart. So I built another Viz that took a look at the number of days post restart. So this is 1 day, 2 days, 3 days, 4 days. Each line, each vertical line is another day after restart. And then I just overlaid the colors on top of each other over several different weeks where we did restarts. And we saw the same wave pattern time and time again. And so we actually were able to send that to the dev team and say, hey, you know, why is this? Why is server behaving this way? When we do a restart, it's fast, and then it starts getting slower, and then it reverts back to somewhat normal behavior again. So it's been useful. Okay, so yeah, kind of going overview again. It's been very useful. We monitor this Viz with a data-driven alert, stock Tableau server functionality. It runs hourly because we're incrementing that TS web request data source, and we're incrementing that. And so every time that's incremented, the data-driven alert will test our Viz. A threshold we use is 0.2 for that median on the blue and orange chart at the top, which weights each Viz equally. You can play around with that. I feel like it's a little noisy for us, but that's something that's kind of up to every server admin, I think. Hourly is the cadence that we've chosen because otherwise we don't have quite enough data to really gauge if there's a performance issue or not. The problems we've most often found have been failing processes on Tableau server. So it's either VizQL is misbehaving or some other process is misbehaving and we have to go and kill it or take some other action to unblock it. Because we have the breakout between the workers, it's pretty easy to pinpoint which one to remote into to take a look at. CPU data can be really useful in this scenario because oftentimes performance issues are correlated to CPU utilization. And so if you have Tableau running or you have other solutions where you can pull that dashboard, pull that data into the overall performance dashboard as another pane and align the axes so the times line up, that can be really useful because you can just jump right into which process is having an issue. And like I said, it helps find other issues, just having the data available to visualize. We can see when popular Vizes stop being looked at, which usually indicates some kind of problem with them, and the performance patterns that we established. Some caveats, as always. So this Viz is good for detecting acute performance issues, so things that happen suddenly. It's not as good at detecting chronic ones. So if you're having a slow degradation over time, it's not going to be as good for catching that or visualizing that because it's resetting its baseline every week. But it's very good at detecting sudden poor performance. It can't really objectively answer whether your Vizes are slower. Everything is calculated on a relative basis. So it's all up to how your Vizes are behaving in the previous week. And that's what it considers normal. Yeah, it's a little bit limited prescriptively. Again, having that CPU memory host data is really important to have. It does break things out for you on the Viz level and on the worker level, but it can't tell you exactly what the problem is. You can't always detect database problems. So if you have a data warehouse your Vizes connect to that's having an issue, there's not really a great way to tell whether it's specific to, say, your SQL Server database as opposed to Tableau Server. Maybe Data Catalog will help with that when it comes out. It doesn't also help troubleshoot individual Vizes. So you don't know why a given Viz is slow. It doesn't do perf recordings. Basically, you can't break it down any more than the Viz rendering time. We can't look at how long queries took. That information is not stored in the HTTP requests table, so we can't get it. And of course, like with all alerts, you're going to get some imperfect ones that are false positives. And we get a lot that actually probably do indicate a performance issue, but people don't notice them. So it might be that they just kind of put up with it and they don't complain, or it happens so quickly and goes away again that nobody gets a chance to complain. So those are sort of false positives in that even if it's a real performance issue, it's not bothering people enough to actually say something about it. And that is the end of the presentation. I will make the, yeah, I have a sample workbook that I will share with Mark to post on the recording when it gets posted. So,
right. Then you answered one of those questions already. It's 2 questions from Doug. Okay. Why not we take just 2 minutes, just answer a few other quick questions over there.
Okay.
Before Lauren start.
So, okay. Do you want to tell me which one you want me to answer, or do you want to just?
Yeah, there are not so many here left. Okay. The first one is from Antonio Flowers. Is there any metrics that can be used to determine network latency issue?
Not.
Okay. Maybe I'll jump in. Whatever you see here from Matt is nothing to do with network latency. It's only what you see on the server. Actually, I had to deal with network latency recently. How we measure is that someone smart develop a Python script from that will be running from user's PC or Mac. That's what the script does is just open the browser automatically, and then capture what is render time end to end from browser perspective. Then we run the same scripts from different countries. Actually highlights me a pretty big latency difference across the ocean. That was actually recently first time I was able to see that data.
That's cool. That's really useful. Yep. So no, it doesn't. You're gonna have to get that data from other sources, unfortunately. All right. Think you need parentheses in calc for duration of Viz Load last week's average standard deviation. Cool. I will check that out. Thank you.
Okay. And that one is very long.
This is, yeah.
Yeah, I don't think it's for server thing. And Chataya, you have a long question about if that can be done using Tableau desktop. Probably sorry, what default this question, sorry.
Yeah, I'll try and I captured it on, I took a screenshot, so I'll try and capture that and post it to the recording.
Jeff has a good question. That's also my question about the performance degradation.
Why is it slightly degrade?
Yeah, do you find your answer after restart a server?
Nope, I don't. I don't have answers on that yet. We're continuing to pursue it, but yeah.
Jeff, it also happened to me at least once. One time that my server, we did not, the scripts to do the cleanup failed. So then the server becomes slower. So what I found from my case was memory. Then since then we do every single week server restart, just make sure we clean all the memory stuff. Of course, other than memory, now we know there's temp files on the system, temp files also on the Postgres.
Yeah. Yep. Is Tableau going to fix slow render for all the admin views that come with server? There's a lot of different things happening right now. I can't speak to any specifics of what's happening there, but they're aware of the problem, and I know that they have several ideas on how they are hoping to improve the whole admin experience, especially around admin views. So I wish I could share more, but yeah, there's stuff happening is what I can say. It's a great workbook to detect VizQL performance. Do you have any workbooks for backgrounders? That's a great question. So the post that I highlighted on the community has a data source called TS background tasks. And that is kind of the same idea as the TS web request, except that it's for backgrounders. So you can use that. I don't have any workbooks ready to share that help you analyze backgrounder performance, but there is a duration field in there that you can use to build your own vizzes if you'd like. Chung Lao, yeah, you downloaded the TS web request from the community post, but it's blank. So what you need to do is take a data extract and make sure that it is incrementing on the ID field. There's no vizzes built for it. It's just a data source right now. So you have to build your own viz still. There's the other data sources that I put up there. Some of them have sort of sample views that give you an idea of how to work with the data source, but they're not really none of the stuff on that post is intended to be out of the box admin views. Really what they're supposed to be is a baseline set of data that's already pre-joined and pre-curated for you to build your own views. So if you know somebody that's good at building Tableau visualizations, talk to them and give them that data and work with them because they will help you build some great vizzes. How to determine the workbook load times, meaning initial view of the workbook might load faster than the others. Trying to figure out how to interpret that. So it hasn't really been my experience. Normally because of caching, I would expect the initial view of a workbook to be slower than the others. But and we're talking about a viz level stuff, so it would be on the view level, not the workbook. If you didn't want the workbook, you could just aggregate the individual viz loads to the workbook, I suppose. Yeah, I'm not sure how to interpret that question exactly, but the duration field is telling you how fast things are.
Yeah, I think we're good.
Okay.
We will have more KOA time at the end of Lauren's presentation. Lawrence, why don't you take it over from here? Thank you very much, Matt.
Yeah, thank you.
Yeah, we see your slide. But we cannot hear you. Only if you're mute.
Oh, hi there.
There we go.
Thank you for having me. My name is Lauren Balush. I'm working at Star Schema Ltd. I'm working as a Tableau server administrator for a bit more than 4 years now. And I would like to discuss the catastrophic events when someone is looking for their content and it cannot be found. I'm not sure if you've been older, but there were probably some of you who had issues with taking backups, restoring content, finding out where lost stuff go. So here we go. First, I would like to let you know the agenda for this short session. I would like to discuss how can you take a backup, what are the methods to do that. I would like to let you know how you can do object level backup and versioning, and also talk about disaster recovery. First things first, the backup tools you can use and should use are TSM Backup. The exact command is, of course, TSM Maintenance Backup and its pair TSM Maintenance Restore, which we will discuss in a short. Site export import, which is more specific to site-related content backups. We will talk about a bit for Tableau Server REST API, what can it do for you. I will mention storage level snapshots as a possibility, and we will discuss other options. So everyone's favorite should be TSM Backup. This is basically the workhorse of taking backups and to securing our content from Tableau servers on an enterprise environment. What it does is it basically gets our full data from the repository engine, which stores all the metadata, user infos, workbook infos, even the XMS for our workbooks and data sources. And additionally, it will get you all the data engine folder contents which you store your extracts, which obviously some people really like, and the revision history. And it's all being put together to a file which is named TSBack, which is short for Tableau Server Backup, I guess. Here is a screenshot about how it looks like. It's basically a zip file with a custom extension, and here you can see it's a medium-sized file, which is a bit over 1 gigabyte. Terabytes. As you can see, the compression is quite heavy on this. You can see it almost half down the extract and revisions, and made half of the repository dump, which is here with the extension PG dump. It also contains some additional files like the config YAML, which have some information about your server environment, and also a key store file and asset keys, which is specific to your installation. What you should know about Tableau TSM Backup is that it can take a long time depending on the configuration of the hardware you're using, the amount of content you have, especially the amount of extracts you have. And it can have, depending on the specifics on your environment, it can take a big impact on how the server is performing during the backup is running, since it's using a single-threaded 7-zip command line tool, which is included in the server installation to zip everything together. And if you're doing it during prime hours, it can have a negative impact on your VSQL performance, for example, if you're sharing it with other processes, of course. As this is a quite IO heavy operation to do a backup, you obviously can do it overnight, but if you are doing it only overnight, then there could be a gap between the backups taken, and there can be theoretically some kind of data loss, which are not captured in case of there is an event you want to avoid when the server is lost, data is lost, disk is lost, or whatever happens. And this is something you can try to minimize by running the backups more frequently or using other methods we will discuss a bit later. Also, TSM Backup does not have the option for you to select specific portion of the content you want to take care of. It will take always the full server contents. So you cannot have, like, for example, in a multi-site environment, to just take 1 or 2 or any portion of the data. It will give you everything, which is a nice thing, of course, but you need to prepare for that you can't easily have like selective content backups. The question might arise, can we do this file, since it's a zip file and this looks very easy to understand, can we do it without TSM? Of course you can. There is an option for you to zip together the data engine folder if you want to, and gather these files which are associated with your Tableau server installation. These are readily available. And also using the internal Postgres engine, you can create your own workgroup repository dump file as well. If there is some gain from you, where you can have additional benefit from doing it in any other way, you can do that and use it. There are also some options if you If you want to make it a bit faster, since it's a quite time-consuming process if you have a large installation. For example, there is the option to use PG-only switch in TSM Maintenance Backup, which only takes the repository without having the extracts and revisions with it. And it should be fairly fast, since the repository is usually between 10 and maybe 70, 80 gigabytes in size. So it's much less disk space requirement compared to having all the extracts and additional files. The skip compression uses a specific option to use with 7-zip. It makes zero compression actually, instead of having the default MX1 option, I believe, which is using a fast but still CPU intensive compression method. So you can do that if you have the space. It will make basically like the same size of TSBack file as you have with your file store, adding, of course, the repository and some additional files. The skip verification option, however, will spare you the time needed to check the repository consistency after the backup was taken. I would not use this option, since it's usually taking only a very small amount of time, and it can spare you some headache if your repository has some invalid values or other type of inconsistencies when you need to restore it. There is also a tip you might want to include in your maintenance scripts, is that using the request timeout setting is defaulted to 30 minutes. And basically, if you have like a large installation and your disk IO is not the best, then you might want to check it and periodically adjust to a suitably high value, for example, allowing it to run for several hours or even longer time to not have broken backups. Whenever a backup process is meeting a timeout value, which you didn't adjust manually or didn't adjust high enough, you will find it in the TSM jobs list. It will have a timeout error notification on it. Tableau does include a selective method for exporting content. This is the TSM sites export and import. This is what you can have for exporting complete sites along with user data with all the content. What it does, it basically gives you the option to export a full site along all the content. What the drawback is, during export operation, as opposed to the backup operation, it will lock down the source site, so no users can do any kind of activity during this export process being ran. Additional steps to import it in times when you need to restore it. First, you need to run a verification type of job, which is basically TSM sites import. In this run, it will create additional CSV files where you can check up if the target site where you are wanting to import your content into is matching up with the dependencies of the original site. For example, you need to match user IDs, you need to match schedule IDs, and of course, you need to match the site's name as well. However, it can be a very time-consuming process in cases where you do not have a very well prepared matching environment on the target side of the things, because you would need to probably using the CSV user import method, add all the users you have on the original site, and also you have to go through obviously a manual method to create all the schedules which are being used in the original site. There is the additional task of course, if these are not necessarily needed or not matching your idea with the schedules on the target environment, that you need to get rid of the surplus stuff. Sometimes it's a more time-conscious method to do a full TSM backup and restoration on the target site, and target server, and get rid of everything but the stuff you actually wanted to export. For example, if you need to move 2 or more sites together, it's easier to move the full server if the space is available on the target side, of course, and delete everything afterward. It will be less effort from the administration perspective. You can use Tableau Server's built-in REST API, which is a web-based API, to move content in a specific way. You can download data from it. You can query workbooks, you can query data sources, and then use it and publish it to a target server using the same REST API method, or even TabCMD if you want to. There are some limitations, however, which affects REST API in the current release. For example, you cannot retrieve comment field and other metadata, which are available on the repository level only. You cannot retrieve embedded data source password, which can be a pain if your users are using it, because you would have to ask them and gather all the passwords and make a script which makes it available for publishing all those data sources back to the target server. Also, since REST API uses the same engine as Tableau Server does for regular users, it can give you a bit of strain if you are doing like a methodological full backup of the server where all the requests go through VizQL, data engine, data server, etc. So it's not accessing them as on the file level, but more like on the process level. We will return to this bit in a later mode. There is also an option, which is highly theoretical at the moment, to do storage level snapshots. What I mean here is that you can mount your file store folder in a network location and then use your network environment, probably a SAN or a NAS, to take regular snapshots of this given folder. And these snapshots can be matched with, for example, a TSM Backup snapshot with running the PG only option with the same periodicity, like every 2 hours, 4 hours, whichever interval fits you, and then try to restore them from your network storage in case of a catastrophic failure when, for example, there is data loss, and use the repository content to back it up to a server from the same point in time. This has been not tested, but it's a theoretical option you can go, which gives you a bit of advantage in terms of restoration time, how much time it takes to get back to your content. Now I would like to talk to you about object level solution. For example, Star Schema developed a small script, Python script actually, which you can have from GitLab. It's free, it's open source, you can check it out right now if you want to. What does it do? It basically uses the Tableau Server REST API to download workbooks and data sources from all sites, all projects. But what it actually processes on them is getting rid of every extracts or binary data. It keeps only the XMS, and after it finishes scraping the repository for them, it synchronizes these files to Git. What we'll give you is having some external versioning system, which of course you have with Tableau Server itself. If you publish over content, you can have revisions to a certain level. By default, it's 25, but you can have unlimited revisions as well if you want to. But there is a caveat with Tableau's internal solution. If you delete a piece of content, for example, a workbook or a published data source, this will be irreversibly lost from the current state of the server. There is no way to restore it with an easy method. You would need to rely on your backup solutions, site export or TSM Backup, create a TSBack file to restore it to a target server, which you can use, for example, a sandbox server, and get the piece you wanted to restore. However, having it on GitHub or your own Git storage, you can keep only the XML, which is the valuable part, since you can recreate extracts with a fresh run and give you an external versioning history. And of course, you can keep the files even after deletion happens. Also, there is an additional value to this tool having it on Git, is that after syncing it all to Git, you can have a very quick, very effective search facility, which can be used, for example, to find out specific data objects. Like, there is a solution to find a specific database table, which should be referred in some files, but you don't know all the workbooks you use them into. You can just search for it right now and have the results in a second. This is something you right now cannot do it in Tableau server, but from what I heard, it's an upcoming feature in 2019.3 as a separate component. Also, which can be a pain at some time, you can even search for custom queries, which is obviously something which is something you want to have if you have, for example, a large deployment with lots of developers doing their own stuff in a semi-self-service way, where there is no revision control before publication happens. And if you retroactively want to find out data and how it's being used, you can have it with this tool. Here is a screenshot about how it looks like on Git. It's actually on a GitHub. You can see there is the GUID embedded into all the data source and workbook file names to make it unique across the whole server. And you can see the XML data source here is presented, easily searchable, easily copyable, and you can have all the revisions. You can run this tool in periodic interval if you want, or just full refresh of the data. It can be run every 2-3 hours, and it uses a point in time logic to match it against the last modification data from the repository. So it will only try to download only those files which has been modified in a certain time. Let's talk about disaster recovery. First, I would like to mention there is a great white paper available on Tableau.com about disaster recoveries. What are the terms? What is the jargon? How it looks like? What are the advised ways to do that? And what are the drawbacks of certain operations? The definitions used in disaster recovery is cold, warm, and hot environments, depending on how it's being prepared and how it's being utilized in an event called catastrophic failure, where you need to restore server functionality in a short amount of time. For example, one option you can take if you want to have the smallest possible time delay between switching over to a new server cluster to have your users back online is to have basically two environments which are being called hot with these terms, and have constant backups taken on the original environment and constantly being restored in the background to the disaster recovery environment. What makes it great is that you can have a very small time delay between setting up the new cluster. If you have, for example, a load balancer in front of the two clusters, you can make the switch over in a couple of minutes, and the only delay users will experience in terms of data quality is the delay you can have with the two backups taken interval. For example, if you run each backup back to back, you can have only a couple of minutes to maybe 1-2 hours, depending on the size of the installation and the speed the backups is taken. There is an approach which is called in the Tableau white paper as medium RTO. RTO means recovery time objective, so the time you are aiming for to have your site back. In that term, you can use a warm site, which is a warm disaster recovery cluster where this cluster is being set up already and maybe have 1 or 2 backups restored, but only gets restored to the actual content when the failure happens on the original server. So in that case, you would need to go over the process of starting a restoration, making the topology up to date, so the process distribution is the same as the original one, and switching it on, for example, on your load balancer to be accessible for users in the company. The highest RTO, so the slowest backup solution, is when the failure happens, you will start looking for servers. You can set up a Tableau server on. You will go through the process of installation, activating your licenses, grabbing your TSBack file, copying it over, and restoring the content. These are the methods mentioned in this white paper, and these are all great methods you can use if you have the capacity and the budget to have 2 environments prepared for disaster recovery. Let's talk about other methods of replication of data. In this concept, it's using the Tableau Server's REST API to replicate data between 2 clusters. In the first column, you will see the active cluster having the repository being pulled by a replication agent, which is a theoretical tool for content changes. After the query is being served by the source server's REST API, it can trigger a download event for workbooks and data sources and other type of metadata like projects being created, user added, etc. And then going through the process of publishing it on the target, disaster recovery cluster's REST API. However, there are some drawbacks to this method, as I discussed in the REST API slide, that, for example, there are some material you just cannot use with REST API. For example, workbook comments cannot be downloaded. Also, you can not transfer, for example, usage history or other types of historical data to your target server, since these are being generated and kept in the repository and not related to downloadable content. So if you have this, if you want to have the same server environment, the same history, the same traffic analysis, then you cannot use this method, since it will be basically an empty server in terms of usage, but it will be populated with the same data. Additionally, your password has to be shared in some way if you want to use embedded passwords. There can be a licensing impact, since the target site, the target server in this environment can be treated as an active production server, and it can have a license problem since it's a double environment. Also, if you have, for example, workbooks where you share the content to outside of the world, like embedding content into external site, these are all relying on URLs. And URLs in Tableau server are generated upon publishing. And since you are publishing it to a different server, then you can't provoke the server to have the same URL for sure. And this can give you inconsistencies, especially if you're using published data sources in workbooks, since published data sources are referred with URLs as well. Also, the tool to do this is not yet developed, so since it's not existing, it will be hard to use. But it can be created by anyone who takes up the task to develop it. I would like to take some time to discuss another option to do disaster recovery, which is a tool developed by our company called Palette Rescue. what it does, it takes a running server and takes a running standby server, a disaster recovery environment, and it does a streaming replication of data on the fly between them. So it's not using TSM Backup, it's not using repository dumps, but it uses specific methods to reach repository data with the internal Postgres toolset, and uses, for example, on Windows, it uses a Rabba copy method to copy data to the target server constantly on the fly. What we'll give you is the option to have a failover in just a few moments of time, basically instantaneously. Here is a slide where you can see how the logic looks like. GLB in this slide is GitHub's load balancer, which would route between the two clusters. The one on the left is the production, the active cluster, which Rabacopy uses the file store folder to replicate data from, while Postgres replicates from the Postgres repository data. And you will have this rescue agent listening on HTTP to request and propagate data throughout the cluster to other nodes. So they all know what's the status of the synchronization. And on the target side, it will just copy over all the files in synchronization with all the changes in the repository. And whenever a failure happens, you can just use a single button on this interface and switch over to the target environment. It will start the disaster recovery environment with TSM start, and then you can switch over in the load balancer in just moments of time. Of course, there are some limitations. Currently, there is only a Windows version available of this tool. You need to have the same topology on the disaster recovery cluster, and also it has the same licensing problem, so you would need to have two active clusters in these terms. Also, you need to have the same process and topology deployment throughout the cluster. So it needs to be an exact replica. If you have any questions, feel free to post to the Q&A button on Zoom. Thank you for your attention.
Thank you. Thank you very much, Lawrence. Any questions for Lawrence or for Matt? There is one actually pending already from Michael for the PG only backup. If the workbook is published that includes external files, will those be contained in the backup? That's a great question.
Let's see if work is published. No, I don't think so. These should be stored in the file store folder along with the regular extracts. Well, the question is, if you include external files, you will have the option to embed these external files, or you can just link to them. I guess your question means that you want to embed these files, so these are self-contained. But I do believe these can be in the file store folder rather than in the repository.
I also agree with you. But the true question, underlying question is that really how the PG-only backup restore works. If we back up and restore Postgres only, and are we sure the file store?
Well, it should work the way that you do a restoration from a cropped down version of TSBack file, which contains on the repository. It should have all the workbook and data source data published to the target server, but all the extracts will be empty and all the workbooks using extracts will fail to load up. What you would need to do is to select them all and make a manual run extract operation on all of these workbooks and data sources the first time, and then after this extraction happens, then you can start to use these workbooks. So obviously, if you have an extract heavy environment, this is not really the approach you want to take, since it will take you probably a long time, having a big impact on the target databases, etc., etc. But if you have mainly live connections, this can be a very effective way to take backups if you want to cut corners, of course.
Yeah, that makes sense. Any other questions?
Oh yes, yes. The white paper URL. Let me just share it.
Or maybe you can post it in the chat, then everyone can see it.
Yep, sure.
And I'm assuming that a recording will be available, but also those slides, Lauren, if you can also send a slide, we can also attach those slides to the recordings. Any other questions, anyone? Just please press Q&A button to submit any questions. I'm not seeing any open questions at this moment. Victor, just submit one. Lauren, this is for backup again. When we do TSM backup, metadata data only, that's PG only. And the backup file store, I guess, has been done separately. Which folder is for file store to be backup? The one restore store to the same location? That is how the details how to do it.
I believe the question from Victor is about how to use TSM restore if you have PG on option. The answer is you do the same restore as you would do with the full backup. You do not need to specify folders or any other thing. It will not use these. I mean, if you do TSM restore, the only parameter basically you provide is the original file, the backup file, and this will be the TSBack file you created in the first place. But for target environment settings, etc., you do not need to specify anything like that.
Okay.
Oh, I see. So Victor, are you asking that if you want to take a separate backup from the file store, as I mentioned in the network snapshot? It's in your, yes, it is in your Tableau server data folder, tab svc data engine folder. You should have extracts and revisions folder in there. Oh, I can see Tamás is already answering the same. For Victor's question, that you need to copy the snapshot content to the original file store folder of your installation. And yes, it's this Tableau server tab svc data engine folder. Yes, as far as I can remember from scratch, that's the correct one. To Victor. I can see on the chat there is a question from Eric. Any tips for backup restoring to network drive? We've had inconsistent results. From my experience, I've only used Windows-based installations in enterprise deployments. Restoring to network drives or restoring from network drives containing a TSBack file did not succeed. There is a mentioning on Tableau server manual about Windows network drive usage. what it states to you is that you cannot use UNC type of file passes. But when I tried to use restore from a network drive, then I got a message about not using an absolute path, but a relative one, and it did not work. So as far as best practice on Windows, in a usual environment, for example, a standard VM machine or even, of course, a physical one is the best if you have the TSBack file on the same server, locally stored in the local file system where you want to restore to or from. It should be the fastest and most reliable. From Pretty, I got the question, what is the best practice for backup on a single node environment? Well, all the practices we discussed today are working for single nodes as well. So if you have a single node, what I would do is depending on the requirement for disaster recovery and what type of RTO you are aiming for, I would do daily backups. This is basically the cookie cutter for Tableau admins. And if you can have the disk IO to spare and the space to spare, then I would do midday backups as well. So the data loss you can experience is the lowest in that way. On a couple hours worth of usage could be lost theoretically. And of course, having the backups copied to a safe location, especially through network to a different data center or different physical location, would be the best. From Eric, to follow upon that, then the backup restore takes 2-3 times the time storage space. Currently we have 330 gigs for backup and require 1 terabyte free space. Is there any better way to not require so much free space? It seems quite wasteful. Our server is 600 gigs. Yes, I know about this problem. When you take a backup, it creates basically a zip version of your file store and copies it to the initial node you're running the backup from. And then it creates a temporary file where it puts together with the Postgres engine, and then again creates the target file you wish to create in the first place. And yes, I believe this process could be optimized.
Good question. We have the same challenge. Yeah.
Yeah, it's something you for the moment need to live with, I guess. You need to be aware of it. So if you have like server monitoring tool, you should set the threshold to a much higher value on your backup node as you would do normally. Also, I would make feature request on the community forum about this to have either customization available, how the backups work. For example, if you can have like selective options to not do temporary files or store the temporary files on another drive, as you would do. You can play with your environment settings as well. For example, if you have a spare drive which have the amount of space you want to use, you can specify some temporary folders in TSM configuration options as well, which might help you out.
Good idea. I think we're running out of time. Thank you very much, Laurent and Matt, for your awesome presentation. For the audience, thank you for attending this today's virtual server admin presentation. We'll try to schedule next one a few weeks out, either focusing on automation, looks like we're focusing on automation. If anyone has any good topic, feel free to let me know. Have a great day, everyone. Bye.
Thanks, Mark.
Thank you, Mark.